Okay. Hello? Can you guys hear me? Sort of. Okay, that's great. Thank you. Hello, I'm Simon from PredictionIO. Thanks for coming here. Excited to see Scala developers, Scala fans gathered here having pizza, and hopefully you'll find the talk useful to you. So, building machine learning applications is tough. It's very tough. You need to manage the algorithm, you need to manage the framework. It's a lot of things you need to worry about. We built PredictionIO, an open source machine learning server for developers and data scientists to build smarter applications, hopefully in a fraction of the time. So we have undergone a lot of changes from 0.7 to 0.8, and today just want to briefly talk about some of the architecture changes and why it is important for the Scala developer community and for developers in general. Before we talk about PredictionIO, I want to mention some tools that are popular in the machine learning community. How many of you have heard of Apache, Hadoop, Spark, or MLlib, this kind of tools? Raise your hand. All right, everyone here is data science expert. So in the Apache ecosystem or the JVM ecosystem, there are already a lot of tools available for processing big data. Apache, Spark, Mahao, machine learning library algorithms. You don't need to write from scratch. There are a lot of them available. Spark, MLlib, Hadoop, H2O, deep learning for J. And for big data storage, you have HBase, Cassandra. So what is really missing if we developers want to build smart applications or machine learning applications for production? The thing that we think is missing is bringing the things that you built with, let's say, Spark MLlib, prototyping it, and bring it into production. What does that mean? Let me give you an example, a textbook example, right? Like if you have read Spark or Hadoop, you might be familiar with a tutorial teaching you how to write a recommendation engine with a few lines of code. I hope it's that easy. So let's assume you have a mobile application, and a classic recommendation case is you have some products, you have some users, and you want to predict what products each user would be interested in. So you can offer personalized recommendation. So you download Spark, it comes with Spark MLlib algorithm library, and you can basically just use it without writing your own library. The pre-pseudo code is very simple. And I'm glad to be here because I don't need to explain to everyone like what the Scala style code means. So the first line is reading data. Let's assume you already have a set of well-formatted data of previous user behavior. Like user 1, like user product A, user 1 purchase product F, for example. So you have this well-defined data format stored in a text file or CSV file. You just need to run this command line and it will read to object training data. And you can pass the training data to an algorithm. We use a collaborative filtering algorithm, ALS. It is one of the algorithms that comes with MLlib. With that, it will return a model, and this is the predictive model. With the predictive model, you can make recommendation. So in this case, we say recommend 5 products to user, and we look through all the users in your system, and so you get 5 recommendations for each user. Nice and easy as a tutorial, but it doesn't work that way on production, right? Can you think of something that is missing here?
Where do you get the data?
Where do you get the data? Data are changing. Text file, or like, so basically how do we integrate with your existing data store? How do we unify data from multiple sources? There are a lot of things that's missing. So beyond prototyping, we also need to worry about scalability. Just making HBase talk to Spark and everything work together with a compatible version is tough enough. Not to mention, you want to deploy your engine as a service. So on real time, on a distributed environment, so it can respond to dynamic inquiries. For example, what if I don't want to recommend 5 products, but I want to recommend two products to someone who is now in Mountain View. And I want to recommend products to another person who is now in San Francisco. So as you can see, not only do recommendations require dynamic querying, but also other prediction problems as well, like classification, regressions, and things like that. So the textbook way or the tutorial way of trying out existing algorithms, they're great, but they're just not ready for production use. And more importantly, for us developers, we care about reusability. We care about maintainability of the code. So going back to the recommendation example, what if I don't want to recommend products that are not in the inventory anymore? There are a number of ways you can do it. You can do a filtering when you serve the result. You can do a filtering when you're actually making the prediction or updating the algorithm. So there are a number of considerations you want to put in. And what if I want to try different things, like to see which one works better? So now we come to the separation of concern, right? Which is like something we have in web development, mobile application development for a long, long time, MVC. But this is something we're missing in the machine learning development community. And of course, PredictionIO is trying to solve the problem. So let me show you what it should look like if we want to build a real recommendation engine on production. Instead of having 3 lines of code, we believe that we need 2 things. One is an event server, and the other one is engine. So event server will be responsible for collecting data from your mobile applications, web applications, email campaigns, analytical tools like Google Analytics or whatever. So basically, it's a unified way to collect all data from multiple channels. So you're looking at one customer from different perspective, and you know exactly what the customer has done, maybe on the mobile application or in the retail store. So everything unified in one place. So based on the unified data, you can create engines. Each engine represents one type of prediction problem. So let's say if you're building Amazon, a website, one recommendation engine is not enough. You need more than one. You might need one in the front page, which helps you to discover new products. You might need one in the product page, which show you people, if you buy this, you might also buy that. You might need another engine for email campaign, like based on what you have browsed in the past 3 days, recommend me something that basically you want to get the customers back to the website. So collectively, we can call all them recommendation engine. But in fact, we're building different engines for different purpose. So we need a framework that can support this kind of development. The frog is PredictionIO.
Oh, quick question. So regarding the event server, is one of the presuppositions is that all of these disparate data sources are collected and then put in some unified way?
Yes.
Okay.
So we'll go into, the question is how does the event server work, basically. I'll go into the details very, very quickly. So just illustrate a scenario. You have a mobile application, and you have the event server, and you have built one recommendation engine with PredictionIO. The mobile application will send data, the user behavior data, to the event server continuously or in a batch mode. It's up to you. And a predictive model will be trained, and the engine will be deployed as a web service. So now your mobile application can communicate with the engine through the REST API interface automatically provided by the PredictionIO platform. We also have a lot of contributors who have built Node.js SDK, of course Scala SDK, Python SDK for this kind of stuff. And the engine will return the predicted result in JSON format as well through the REST interface. So this is how we envision a production environment of recommendation system should be. So now let's talk about event server, which is the relatively simple part. After you install PredictionIO, launching the event server is simple. Just one command line, PIO event server. The event server is built on HBase. So if you ask how scalable, how elastic the event server is, it's just as scalable as HBase. And using it is really simple. We define the event language, just like if you're familiar with analytical tools, it's very similar. In this case, user 1, 2, 3, give a rating of 5 to item 100. You can define the product's name, attributes name, actions in 3 formats. You can also say the price of the product has changed, so you do a set action on it. So it's flexible enough to collect most type of events or data that you might have from different channels.
Can you reset cookies as well, like 30 days or 2 days of the user's visit?
Sure. Yeah, the question is, can we set cookie as well for users or visitors who haven't logged in yet? So in this case, maybe the event type would be visitor instead of user, and the entity ID would be the cookie ID instead of like a user email address or user login ID, and you can collect it the same way, basically. So now let's say we have collected the data we need for building recommendation or other prediction tests through the event server. The next thing we can do is build engines. That's the fun part, right? Collected the data, now we need to build our first engine. Building an engine is easy. We offer a lot of templates. So basically you just download the template, recommendation, classification, templates, and you can get it up and running within a few minutes. But of course, we need to get deeper into it today because you guys are Scala expert. We probably should talk more about like what is it inside an engine. So this is the fun part. This is what we invented or developed it in the past few months. It's a DASE architecture, DASE. Does it sound much better than MVC? MVC, you cannot pronounce it, but DASE is a name. So, but it's actually the MVC for machine learning. D stands for data source and data preparator. As you can imagine, it pulls data from the event server, but you can also modify it to pull data from your existing data source as well. So if you don't like the event server, or if you want to use the event server with some of your existing data store, you can modify the data source components of each engine. Data preparator. If you have done some data cleansing work or feature selection work before, you might be aware that a lot of logics involve data cleansing when you're doing machine learning tests. And sometimes you want to try different ways of data cleansing. Like you might be sampling 10% of data one time, you might be sampling 20% of data another time. So by having the data preparator component, you can swap it out and swap it in and compare multiple engines. So this is the beauty of separating data source and data preparator component. And then we have algorithm components or algorithms. It depends how many algorithms you want to implement in a single engine. So for example, we can start with a very simple trending algorithm, non-personalized. So it just recommends products that are the hardest to the customer, to every customer. And then you can add another algorithm, which is personalized algorithm for customers that have already purchased something in the past. And you can combine this result of 2 algorithms in the serving components. And there's also an evaluation component for you to evaluate how good the engine is using. So it's like the MVC for machine learning. We separate it to D, A, S, and E. So in summary, the function of an engine is to train data and create a model and deploy it as a web service. And also, it will respond to dynamic queries. When your mobile application send a query, give me certain prediction, it will return results to it. And the third function is evaluation, which I'm not going to go through evaluation today. But let's take a look at the first thing, train a predictive model. It is a better visualized way to see how the components work together. So your data is in the event server now. You pull data into the data source, and in the class, you can do all kinds of stuff and return the training data object. PredictionIO will pass it to data preparator automatically. Data preparator, you do all kinds of data cleansing stuff, and you can throw out a prepared data object, and it will be passed to all the algorithm class automatically. In the algorithm class, you just return a model. So remember in the text prototyping example, you do 3 lines of code. Read the data file, train the model, And the model is not persist. So you need to loop through all users and cache the results. But here, all you need to do is just, in your algorithm class, the function, return the model. And PredictionIO will cache it and will persist the model, and will return it to you when you need to make recommendation. So there are two ways of doing it. If your model is, for example, in RDD format, in the distributed object format of Spark, you can just return it and PredictionIO will cache it. We also provide another class interface for local model objects as well. So we support both distributed object and non-distributed objects in this case. So more on the code level now, instead of the visual level. You build the engine code, DAs, SE components are ready. In order to train the model, all you need to do is run a command line, PIO train. It will trigger the retraining function of the data source class. You do all kind of stuff there. Return training data. Training data will be passed to the prepare function of preparator, and you do other stuff there. Return the prepared data. And prepared data will be passed to the train function of algorithm, and you return the model. So if you go to our GitHub or website and download one of the engine templates, be it recommendation or classification, you will see the class files like that, separated cleanly. So if you want to modify any component, you can just modify that class or that function. So the next thing is, okay, now we have an engine that can read data, train a model, and be deployed as a web service. So how do I control the logics that it responds to dynamic query from your application? Again, a more attractive visual graph is like this. Mobile applications send in a query. The query is in JSON format. And PredictionIO will convert it to be like a case class objects and pass it into algorithm. Algorithm, given that you already have a model, you can make prediction. You return the prediction to a serving class. Serving class, you can do the real-time business logics. As I mentioned, there might be a blacklist, you want to filter out something, or you might want to combine results from multiple algorithms. And then you can return the predicted results as an object. The PredictionIO platform will convert the objects to JSON format and return it to the clients automatically. And naturally, we support multiple algorithms in the framework. A little bit more coding. So how do I define the input and output format? So in this case, we're building recommendation engine, right? So the natural input would be a user ID and the number of products that I want to recommend to the user, which is something like this, the JSON format. In order for engine to take that JSON format as a query, you define a case class, variable name, user, variable number, and make it serializable. That's all you need to do. The same way, how do you define the output format? If you look at the code, you'll be able to find this class, which essentially just return a list of items with an item ID and score. So it is just that simple. You don't need to worry about the JSON Scala objects conversion. It's all automated. So the two classes that are responsible for responding to dynamic queries are algorithm class and serving class. And remember, we used algorithm class when we trained the model already. But this time, instead of using the train function, we defined the predict function. So the mobile application send a query to PredictionIO platform, which will trigger the predict function of all the algorithm classes that you have defined it, and pass you back the model. In this case, the model is the ALS model, but it can be other models if you're using other algorithms. And you make the prediction and return the predicted result. PredictionIO will pass it to the serve function of serving and return the predicted result. Sorry. So all these DASE components are controlled by one object. It's a factory. We call it an engine factory. And you define the name of the classes responsible for the architecture. So it's all clear and easy to be customized. It's customizable if you just want to modify the engines. Sorry. So in summary, we built a machine learning server for all of us to develop and, more importantly, deploy machine learning applications on production. And the bonus part is the whole stack is open source, and we built on top of Apache Spark, HBase, and Spray framework for the REST interface, API interface. So, and we have also integrated Apache ML algorithm. It is easy to integrate other algorithm libraries into it. We're working on a number of them, and you can also add your own algorithms on it. So we have got a lot of complaints previously, like I cannot put Spark talking to HBase, the version is incompatible and things like that. So we have made an install script, one line of code. You can install the whole stack. We also have like Docker, Vagrant, Amazon AMI. So one line of code, you get the whole stack up and running. And you can start from single machine. I always try it on my laptop, but it's scalable to a cluster, hundreds of nodes as well. Because again, we're as scalable as HBase, as fast as Spark, because we use those open source technology as our underlying base. So you can launch an event server. You can deploy an engine with PIO build, PIO train, and PIO deploy. And when there's new data coming in, which is very important, when you build your own prototype, you might not think about it. But on production, it is very important that you keep having new data coming into the event server. In order to update the model, you just need to run PIO train and PIO deploy again. The model will be new model will be trained and will be exchanged to the existing model. But of course, you can also use other like DevOps architecture like Chef to make it more robust if you need. So this is the architecture that we think everyone will need when you're building machine learning application. Several applications, mobile applications, web applications, everything sent to the unified storage, which is the event server, and you can build all type of engines on top of it. You can also do experiments. You can evaluate which engine is better than the other through this architecture. And all your source code is reusable. So this is the end of the quick talk, and love to get more questions. If you want a quick start, really start from an engine template instead of writing everything from scratch. You'll be able to see how each components work. Everything is on GitHub, and we're quite a young project. We have made a lot of changes in our new version, and we need your feedback, especially Scala expert, right? Like we need your feedback, we need your input, and make it a better project. So no matter you're contributing or using it, tell us what you think. So thank you. There's a question,
So maybe I missed this part, but can you say in one sentence what is the problem you're solving?
Sure. So the question is, what is the problem we're solving? The problem is difficult to explain it in one sentence because it's a problem I've been facing in the past at least 6 years when I'm building my application. So the problem is actually building machine learning application is hard. The ROI is very low, and we're providing a tool so that developers can forget about a lot of tedious work and they can use PredictionIO to build it much faster in a fraction of the time. So you can build the whole architecture by yourself, and you can maintain it by yourself. It's just like when you're building a web application, you can build everything from Scala, from Python, from scratch by yourself. But most people would choose to use a web framework, and it's the same here.
Would you say it's sort of like a lab stack for data analytics?
Yes, it's kind of like a LAMP stack for data analytics.
You can have that.
That's a good analogy. Thank you.
When you talk about this prediction engine framework, because it feels like, especially in machine learning applications or data science analytics, a lot of time was spending actually on trying to transform your raw data into somehow formatted data. You can apply whatever matrix factorization, or rapid filtering, whatever model, right? So that part, how does PredictionIO can help?
Sure. So the question is, in a lot of machine learning tasks, you need to spend a lot of time to transform the raw data into useful data or the metrics.
Yeah,
so
that's one thing.
And
another thing is like it's very likely your data is spread into multiple sources,
right,
from multiple sources. Right?
So the other question is, usually the data is spread into multiple sources. So one way we solve it is provide a unified way for you to aggregate event data, like that's the event server. So it's flexible enough. We have built like connectors to mail campaigns, Google Analytics, web applications, things like that. So that's one way that you can unify all your data in the standard format. So all your engines will follow the same format. And that's the whole reason why we have built the event server. But it might not solve the problem completely, because in some cases, you don't want to stream all your data into event server, especially in a large corporation, you already have the architecture up and running. So in that case, you can actually modify the data source component of an engine. If you're only building one engine, it doesn't help you much. You still need to write all the code pulling data from your existing data source into an engine. But the good thing is the components are reusable. So after someone has done it for like the first recommendation engines, you can actually reuse the same data source code in another engine. So hopefully by introducing a better software design pattern, a large group of data scientists and developers can work together to solve. So they save a lot of time.
Actually, I have two questions. One is, in your system, do you have a notion of tendency? Because in our production, there are actually different teams that are doing all different kind of stuff. They may share data, they may not, and they may share models, they may not. So do you have a tendency notion that, so that when we have full control of who is doing what? So that's one question. The other question is, in your persistent layer, especially for the model, do you have this concept of versioning? Like if I generate a new model, do I have a newer version of the model, or I override the old model?
Great questions. Love to talk to you more about it afterward, because that's, you touch upon a lot of advanced features that we have already developed, but I didn't include it in the talk and also in our documentation. But we'd love to get more real user feedbacks. A number of companies are using it already. So sorry, I need to repeat the question. The first question is tendency. Like, do we support multi-tendency? The other question is versioning of the model, like the algorithm model. Do we do versioning? First question. Yes, we support multi-tenancy through a concept called app. So when you input the data to event server, you create an app first. It gives you an app ID. So you separate the data through like the app ID basically. But we haven't introduced the security separation of tenancy yet. We can do that for maybe enterprise surface or things like that, but that's not included in the product at this moment. But if you're just thinking about logically, you want to separate the data, is the app ID concept.
Separate data at the engine level, right? Not at the event.
At the event server level.
Too, but
yeah.
Can they share?
The idea is not to share.
Oh, I see. Okay.
But having said that, because the data source component of the engine is open source, so you can modify it to get data from different apps. But theoretically, the reason why we introduced the app ID concept is we want to help you separate data in the event server form layer, so each engine would read one app data ID. The other question is data model versioning. Yes, we support that. We don't have very good user interface to show the versioning, but we already have everything to manage. After you deploy the model, we save the versioning, and you deploy a new model, we save another things. You can revert it as well. But we're working on the documentation right now. It's just that we don't see a lot of real cases using it right now, so the urgency, but we're still working on it. If you need something like that, let me know. We can speed it up.
Well, I can give you a use case.
That's great. All right, cool.
Can you tell us something about your ecosystem of developers? How many people you have contributing to this? How you've worked with development organizations? Some of the things that you've learned from your users.
Right. We want to make it as open source, as open as possible. I think we're one of the very few machine learning products that are completely open source. A lot of companies are building machine learning solution as a black box, but we just don't believe in it. So we have a lot of people following the projects on GitHub, and I think we're featured on GitHub as one of the most popular machine learning products. We have a small team of full-time working on the product, but at the same time, I think we have, on the whole ecosystem, over 100 people working on the project right now, including a lot of connectors to existing platforms like Magento, KeenIO SDKs. We didn't build a lot of SDKs. Most of them are contributors' effort. And we're encouraging more contributors to work on the documentation as well, because we're not good at it. So we love to see what users think about it. But I think users are the best document contributor because they know exactly the use case they need, and they can write it back to say, hey, I need something like this. This is my problem, and this is my solution.
And what success stories in your ecosystem would you highlight?
We're very excited about every production cases that we have. I think we have, like, because it's open source, we don't really know how people are using it, but I think we have over 100 applications running PredictionIO right now, and we receive a lot of feedbacks. If you look at our Google group, the people who ask questions are like ranging from individual developer or student writing an HTML5 game marketplace and they want recommendation to some of the largest insurance company, media company, e-commerce companies using the product. So we're excited about it every day.
So it looks like there's a lot of infrastructure for bringing in algorithms, data management, data pipelines. How about on the visualization side? Because a lot of machine learning algorithm development ends up into a data visualization problem because you want to be able to see your correlation coefficient or prediction accuracy values, area under the curve, whatever it is that you're measuring.
Right.
You want to visualize it. How do you go about large-scale predictions and managing the interactive development part?
Thank you. So the question is about visualization, like how much visualization we provide, because that's so important for people who are building machine learning algorithms, knowing the correlation of data and things like that. That's something we're working on right now, and we hopefully, if things work out well, development, we don't have a very strict like that line. But that's something we're working on right now, and if things work out, we will announce it very soon. So subscribe to our newsletter, and you will know about it. Basically, we're trying to open up the event server so you can do more data visualization, debugging while you're developing the algorithm. And we also want to improve the user interface for versioning. We think versioning is very important for you to see which model works better, and evaluation, better visualization for evaluation as well. So that's something we're working on.
One more question about your evaluator. I think I'm not sure whether your evaluator has considered this online A/B test. For example, in your mobile app, when you have different models, it's very likely you need to do some online A/B tests to make sure actually somehow the offline performance is consistent with the online result, right? So, is it easy to kind of just plug in some online A/B test framework into this PredictionIO, or is it easy to extend some?
Great question. So the question is, how about the evaluation? Do we have the A/B test tools, or do we? How easy it is to integrate existing A/B test tools to PredictionIO? We have seen users using Optimizely, mixed panel on PredictionIO. So it's kind of like the using third-party tools on PredictionIO approach. The way it works is, let's say you deploy 2 engine instances and you want to compare them. Each of them will be listening to a separate port. So in your A/B test tools, you can divert some control group to one port and another control group to experiment group to another port. This way you can do the A/B test with external tools. We see a limitation on this approach is you can find which engines works better, but without knowing what's the problem is, like without looking into the event server directly to see what prediction has been made and why the prediction result is not good, it is very difficult to debug it or tune the algorithm. So it works in a pure evaluation, for pure evaluation purpose, but it doesn't work really well for if you want to tune the algorithms. So we evaluation side is quite new for the product. We have it in place. So if you look at the, usually I don't encourage users to look at it, but we do have an experimental directory which involves some evaluation tools, evaluation code there. I don't normally recommend it to people, especially if they're not familiar with Scala, but since it's more like an advanced group, I can mention it. But we're still changing the user interface of the evaluation. And online evaluation is something we hope to provide in the future, either through our independent product or with some better integration with existing tools.
A follow-up question to that, you mentioned you'll create two different engines, or is it something in single engine we could create two different models and somehow know which algorithm is giving me better results?
Yes. So in each engine, you have a configuration file. So you can specify which algorithm you use. And you can deploy multiple instances for the same engine with basically different instance of an engine. You can deploy it live at the same time. And that's the beauty of the architecture. Like it managed the versioning, it managed deploying multiple instances. So you don't need to build it from scratch by itself.
Another question about you mentioned if we get a new data, we have to train and deploy it again. So how does that work? Is it training based on incremental data, or it has to go through the entire data set again? How fast it could be if I'm getting streaming data and I want to basically give, let's say Netflix classic case, right? I've search some movies and then I want to give recommendation based on that again.
Right. So the question is about new data. Do we need to update the model with all the data, or do we support incremental update or streaming data? Officially, we don't support streaming data right now, but at the same time, you can modify the data source component. So you say you just want to get data up to a certain time period, and then you can use incremental update algorithms in it. It's just that we don't have such incremental algorithm out of the box right now. We do see that in the community there's some effort of integrating Spark streaming into PredictionIO, so it might happen very soon. I think it's much easier now, like given there's a Spark streaming architecture instead of like the Storm architecture, because it's more like you get a small batch of data and you want to update the model. The architecture provides easy way to do it because you can always retrieve the model that is persistent and you can update it. So I don't see why it cannot be done, but it is a good contributor project if you're interested.
Sure. One more thing on that same thing is when I'm doing a train and deploy, what happens to my service which is serving the online request? Is it still working on the previous model and at some point it switches to new, or
right.
How does that work?
So the question is, if you already have an engine up and running and you run PIO train and PIO deploy again, basically updating the model, what will happen? So if you're running one single engine instance and you run PIO train and PIO deploy, it will train the model and then take down the old model and put the new model up. So there's like 0.0 something seconds downtime during that. We do it this way, so it's just for beginners or developers who want to get started quickly. So at least you can update the model easily. But the suggested production mission critical way is you launch an engine instance. When you have new data, you launch another engine instances, and you use something like chef to redirect the flow to another one before you shut down the one. But we have a documentation on it, so we can take a look at it.
Excellent.
Yeah, thank you.
One question.
Sorry, the one in the back here didn't ask something.
Just wondering, how do you manage the dependencies with, say, Spark or HBase? Do you need to be in certain versions?
Yeah, that's a pain. I mean, the question is, how do we manage the dependency of Spark and HBase? Because we actually spend a lot of time figuring out what works and what doesn't work. Because every Spark release, it breaks things at the back. So if you install the whole stack with our command line or through our virtual machine, everything works properly. But if you have your own Spark version and it's not compatible with what we're working on, it will require extra work. There's nothing much we can do on that.
So my question is why do you pick Scala as the base language for PredictionIO? Is that because of Spark?
Very interesting questions. Why do I pick Scala? I must say I love it here. No, but there are not many choices really. Like we obviously we don't want to build it on Python, like performance and large scale development issue. Basically, we want something JVM. We can go for C++ path, but the ecosystem is just not there. Like the HBase, Hadoop, Spark ecosystem is not there. So the choices would be Java and Scala or Conjure. And Scala is if you look at the syntax, it's like a natural language for data scientists, right? Like the map, the parallel processing is just so similar to the map reduce that you're used to in Hadoop. And the language is beautiful. You can have the DSL. Basically, we just love writing Scala, and the performance is comparable to JVM, and it can reuse all existing Java libraries like Mahal. So that's the choice that we choose. And turns out that the type safe makes it much better for enterprise development instead of like any scripting language. So that's our first choice, and we never regret it.
Do you hear any feedback from this, like say, data scientists? I know probably Python, or some people use R, and probably some other people might use SAS.
Write everything in R. Great, go ahead.
Yes, so the question is, I guess it's a comparison between R and like Scala or the ecosystem of Scala. That's the whole point of PredictionIO, actually. Like our personal opinion is great for prototyping, testing the model, but when you want to build enterprise solution, most companies choose Scala nowadays. Like I think LinkedIn, Twitter, Salesforce, most companies prefer like a more enterprise-friendly environment than like R, I believe. But R is a good model if you just have an Excel size of data and you want to try out with it, I think. It's just my personal opinion, no offense to our community.
There's a performance hit with Spark using Python and R because it's got to go outside of JVM. It's on the order of 3 to 10 times. So it's kind of an unfortunate reality if you're going to use Spark.
That's great. I mean, yeah, I do see like if you build on Spark, everything, the ecosystem just work better in terms of performance, in terms of compatibility. Python is also a great language. We actually use Python for some visualization, data analytics stuff. It's fast for prototyping. But when we want to build something that is reusable, maintainable, the JVM size, it looks like a natural choice for us. Great question. Any other questions? All right, thanks for coming.